All right. Okay, so we're here again to find the confidence interval of the using t statistics. Okay, and compared to the last activity or the sample that we have here a sample data. So now we're here to compute for the confidence interval again. But first, we need to check. Okay, we need to check that if the t-statistic distribution is normal. Okay, since we have this raw data, we have the opportunity to test if the data is normal. Okay, because if the data is normal, it's have a normal distribution, we are high probability that that it is correct. Okay, in estimating the total population. Okay, even though this is just a sample, 15 samples. Okay, so to do that, we need to first already have given here the different values to compute. Okay, so first we need to check the total population. Okay, we need to just use count. So there is a total population. Okay, 15. Okay, and by the way, we are testing here the skewness and the kurtosis. Okay, skewness is the measure of distribution shape. Okay, if it is the left and the right tails have the same mound shape. Okay, and for the kurtosis, it is the measure of the it's a measure of how what is the number of outliers. Outliers are here. Okay, they are seen in here. Okay, so what's the level of outliers in here? Okay, and the skewness is the left and right. Okay, so this is just a sample distribution here, the normal z distribution and the t distribution. Okay, we are checking here the t distribution because the t distribution, since this is only 15, okay, we need to check if it is has a normal distribution. Okay, but a number of distribution more than 30, then we can assume that it has a normal distribution. Okay, as long as it has been the data has been collected um, scientifically, okay, systematically. Okay, so we will now check for the skewness. It's just easy. Okay. Level of skewness negative 49, negative 0.49, and the kurtosis. So now that we have the level of skewness and the kurtosis, okay, we will now check for GB statistics. So GB statistics is we will be testing here the how well it's a goodness of fit. Okay, it means that the samples, these 15 samples here, these 15 samples here has a normal distribution. Okay, so that's what we're gonna do. Okay, so this is the computation for the Jarque Bera test. Okay, so first we need to follow this one, the n over the 6. Okay, so n here is 15. Okay, so standard deviation, I mean the s here is the skewness. Okay, and then we raise to the second power. Okay, and the c here is the kurtosis, again raised to the second power, and divided by 4. There. Okay, that is the level of kurtosis that we have. Okay, so now, okay, over 4 C2 2. I think we got the correct answer. Okay, G12. Okay, so now we will compute for the p-value. Okay, sorry, this is following the formula here. This is not a multiplication. So now we will be using chi normality. Okay, right tail probability of chi-square distribution. Okay, this one and then 2. The degrees of freedom is 2. This is the standard rule for the normality, so the degrees of freedom will always be 2. Okay, so since it's 0.73 and it's more than 5, we can conclude here that the data is not normally distributed. Okay, so any answer that we will be deriving here, any estimate that we will be deriving here, the answer is not so valid because the distribution is not normal. Okay, therefore the how it is. We will not proceed with computing the confidence interval. Okay, so I hope you learned something again today, and I'll see you again on the next activity.